Okay, so we're back out in the shop. Going to cut some more reels after I learned a little bit from MCAM Northwest, a little bit of MasterCam training. Got some material, 3/4 inch thick, ultra high density polyethylene, and we're going to stick it in the machine and give it a cut. So all I do is I just have a fixture plate right here. You can see the outline. That's for the large size reels that I cut, or I started to cut for Eliot doing the prototyping work. All I do is just toe clamp this thing down in the corner, and my program, I've got the stock drawn in, and I locate off of the back left corner. So pretty simple. Z height 0 is the fixture plate, and I try to never run into the fixture plate, although obviously you can see I have a couple times, but it's super light. So that's where we're at. Let's get to it. Okay, so we're back at it. I've got the model opened up here in MasterCam, and we can see the tool paths that we worked out with MCAM Northwest. Really cool stuff. 3D high-speed dynamic, 2 sets of tool paths for that, and we can get all of the stock roughed out of the inside of these guys. It should be super efficient. I think I'm just going to run these 2 tool paths and see where we're at, and then work at honing them in, perfecting them, and then I'll add all the contours and drills, and that'll finish up this side. So yeah, I learned a lot from these guys at again MCAM Northwest about like what radial chip thinning is. Again, this is plastic, so coming in here with a perfect chip load per tooth is probably not so critical. It's super forgiving. I can really hog this stuff out fast, but he helped me out with a lot of stuff, and I can highly recommend subscribing to their system. Streaming Teacher, it's a great product to learn. Great for teachers. But in my case, I was fortunate enough to work directly with one of the guys there, and they really helped me out quite a bit. So super fun. It was a good learning experience, and now we're gonna burn through this first set of 3D dynamic high-speed cuts with a 3/4 inch 3-flute end mill. Okay, we did a few parts as a test and perfected the speeds and feeds. Got it all honed in. Took me 3 parts, but we've come up with something that is pretty good. So what we'll do is go ahead and push start here. So the 3/4 comes in, does a helical interpolation down, and cuts the inside of the cover with a 3D dynamic tool path. I got it moving at 3,500 RPM, and I'm 60 inches a minute. It's throwing a really nice chip. Does a little micro lift, 300 inch a minute rapid over to the next cut. This is the tool strategy that MCAM Northwest John over there set me up with. It's a darn good tool path. And this old machine does just fine with this this kind of modern toolpath here. The real high feed rapids back, not a problem. This is a 99 Cincinnati Aero 500 with the achromatic 2100 controls. Now it's going to work its way up. This is a big chamfer, full depth chamfer basically, and it's going to work its way up. And the customer actually agrees that this is just fine. And the chamfer steps that we're cutting here are small enough that this will work just fine. We don't need to run the extra tool path to do the chamfer mill. So that's what it's cutting right here. Okay, we'll go ahead and run through a cycle in real time, just so you can see. About 3,500 RPM, 60 inches a minute. Little over 50% step over on a 3/4 inch 3 flute carbide end mill. And again, in the MasterCam, we have the radial chip thinning option selected. Does a 1/5 of an inch micro lift with 300 inches a minute of back feed. And that's a full depth cut. Material is 3/4 inch thick, and our Z height right now is at 1/4 inch, so this is a 1/2 inch depth of cut. All in one tool path that MCAM Northwest set me up with, John over at MCAM Northwest. All in one tool path here. It's working its way up what should be a chamfer here. It's leaving a little bit of material, but creating a stepped chamfer basically. And my customer has looked at this and he's determined that this is just fine. We don't need to follow this up with a chamfer end mill and smooth this out with a nice 45. This stepping will work just fine. So by having this option available and knowing how to program this, I've actually reduced my need for a whole tool. This is the cover for this fishing reel, and all we're doing here is creating clearance for the gears and the chain. So this is an internal feature. Nothing will be seen from the outside. So this strategy is just fine. All right, now it's going to run over and bore a hole all the way to 0. I think I stay about 5 thousandths of an inch off the fixture plate. So this is 3/4 of an inch. We're 60 inches a minute again, 3,500 RPM. And it's really throwing some chips. We got a little buildup on the end mill, but not too bad. And all in one tool path again. Goes up to this surface and is going to cut this big pocketed area out. This is a 3D dynamic tool path again. We're still at 60 inches a minute, 3,500 RPMs. And here's our little micro lift with our high feedback. 300 inches a minute there. Pretty sure I could cut this at probably 200 inches a minute at this spindle speed. Here's where I get a little buildup on the end mill. We're drilling with this 3/4 inch 3-flute end mill. And I'll go in and knock that off with an air blast. Just can't get that guy off there. These are shallow depth of cut little features that create the interface between the two pieces here. We're right now at 7 minutes and 15 seconds cycle time. I think again we're back up to 60 inches a minute. It's about 65 inches a minute, 3,500 RPM. About 300 thou depth of cut. And now we're 600 thou depth of cut, 40 inches a minute, 3,500 RPM. 8 minutes into the program. This is a deep cut, so I go ahead and do a cleanup pass here and speed up the feed rate. It's about 10 thousandths of an inch that we're taking off here on this surface. At this point, we're done roughing and finishing. So all we have left is drills. These are our motor mount holes. We're feeding this at about 35 inches a minute. Spindle speed is about 2200. You can really be aggressive with this material. And now we're gonna go ahead and grab a 1/4 inch end mill and do a counter bore on those holes. Very high feed rate, about 65 inches a minute, 2700 RPM. And the last drill is for all of the mating screws between the two pieces, and that's a pre-drill for a wood screw. Not sure the size of the drill I've selected there, but we're spinning that at 2700 RPM. Correction, 2300 RPM, and we're feeding at 60 inches a minute. We are 10 minutes 45 seconds into this program. The previous part I cut with my strategy of pocketing took 13 minutes, almost to the T. The only thing that we've changed is we've eliminated the counter, or the chamfer mill, and we've sped up dramatically the pocketing feature with this 3D dynamic toolpath. And by doing that, we're just about finished here. We're at 11 minutes 30 seconds. My version of this, slow version of this, was 13 minutes, and we are 11 minutes 40 seconds. Very impressive. Okay, I got the clamps off. We'll have a look at surface finish on this guy. Maybe hard to come through on the camera, but these little scallops, you can see them. I can barely feel them. They're pretty clean. A little bit on this hole right here, but with plastic, this just comes off with a fingernail. Cleans right up. I'll go over this by hand with a deburring tool anyways. And in here, we're very, very clean. This is a much better surface finish than what I could achieve with pocketing. So, looks really good. So here you can see the body that we cut out from the previous operation. So now in Op 2 on this body, what I have to do is I'll run a screw in. Oh, I got the wrong screw. There we go. I'll run a screw in to kind of do a little starter thread, like that. And then I have a little tool to just take that edge off, so that isn't proud. And then maybe even give it a little shave here. Now that guy's ready to bolt in. Okay, I've just got a plate, a fixture plate in here with 2 holes that correspond with the 2 holes I just ran a starter thread in. I've picked up the edge of this thing so it's repeatable, and then my 0 point is the back left corner here. So what I do is I've got some screws, stick one in the hole, and then find, sometimes I'm good, sometimes I'm not. There it is. Find that hole, that starter hole, and I take this screw and just thread her in. Same thing up front. That's a little easier to find generally. There it is. Get him started. Nice and tight. There it is. Ready to cut. Okay, here's the second side of the main body. And the guys at MCAM Northwest helped me figure out something I've never done before. I've always used SolidWorks to modify the model, bring it into MasterCam, and then do my toolpath. But there's a super cool feature you can see up here, fill holes, and it made this toolpath so much smoother to just fill these holes. So you can see what we've got now. It's just runs around and around and around. High-speed hybrid program. Kind of a big step over, but for this, it's more than adequate to interface with the fishing reel. So I've got a little pocket program up here. I've got the 3D high-speed hybrid cut down here, and then I just run around and do a 2D chamfer around this edge, and that's this cut right here. It's located, the zero point, the origin is actually I made stock with lines around the part, and that corner back there, that's what I use as my 0 point. This is just a simple pocket program, about 100 thou depth, 60 inches a minute, 3,500 RPM again. Cuts right to the finished edge. Now we're going to go get our Now we're going to go grab that 3/16 ball end mill, and away it goes. I think I'm 50 inches a minute at 4,500 RPM. And that's such a smoother cut now that I've plugged all those holes. Before I left them, and it would kind of dance up and down in the Z-axis. But now it just runs around continuously. I think I've got maybe a 20 thou step over. And then we finish up with the chamfer, and that's pretty non-eventful. So that's the whole process. So here's the cut on the cover. It's simply the same 3/4 inch 3 flute carbide end mill running around in a ramp contour. I think I'm taking 80 thou per pass on the ramp. So it runs down to height, and then we clean up the edge, that fuzzy edge in the back there, with a chamfer. Okay, we're just finishing up the ramp. And it's going to go grab the little 45 chamfer mill. Puts about a 200 thou chamfer on that edge. Okay, we've got the covers off of the CNC, and here's the finished product. So this face here will interface with the reel itself, and then the motor will bolt onto this face right here. All this thing does is really adapts the motor to the reel. In this case, it's a Shimano 50, and provide a chamber for the sprockets and chain to live in. So yeah, when it's all said and done, there's a kind of a press fit interference on these two parts, and when it's done well, they go together easily and they stay together. There will be a sealant that goes in this little flange, and there's a whole pile of screws, number 6 flathead screws that go in to bolt the thing together. So that's what we do. And like I said, we saved 11. We went down to 11 minutes. We saved 2 full minutes on just the roughing operation on the first setup. So really impressive, and really want to go ahead and thank MCAM Northwest for the time they gave me, the training, and if anybody's looking for a Mastercam supplier in the Northwest, MCAM Northwest is the way to go. So anyway, thanks a lot for watching, and tune in for the next one.